So now we start with the numericals of the sign conventions, and before we start with the numericals I would better write in a short over here the sign convention so that we are not making any mistakes while doing the sum. So first of all, we know that for in case of convex, u is positive, u is negative, f is positive, v is positive for real image and negative for virtual image. And in case of concave, we can see u is negative, f is negative, and v is also negative. So this is the sign convention what you are going to use. Now let's start with the first sum over here. So the first sum is given here. At what position of the candles? Okay, so you are going to find out the position of the candle to be placed of length 3 centimeters, be placed in front of a convex lens so that its image of 6 centimeter be obtained on a screen placed at a distance of 30 centimeters behind the lens. What is the focal length of the lens of part A? So we see over here, first of all we'll write out the type of lens so that we are not getting confused about the sign convention. You are given that the object is of 3 centimeters and the image is of 6 centimeters. The distance of the it's a real image because it's taken on a screen, so it's a real image, and it is given at a screen is at the 30 centimeters from the lens. That means it will be over here, it is positive because the real image, so it is positive. So no change in the sign. U is going to be what you need to find out, and F is what we need to find out again. So first of all is I upon O is equals to V upon U is the first formula. I being 6, this being 3, V being 30 and U being U. Okay. So accordingly, we see this part. Now of course, we can see over here that the image which is going to be formed is a real, so image will be negative, so that's why it will be negative over here. Or we may not consider it, we already know that U will be negative, so we are not changing anything over here, we are not using any sign convention here. So here it is, this cancels to U2, so U is equals to 30 upon 2 is equals to 15 centimeter. So U is 15 centimeter, and since we are not considered, actually kya hona chahiye, this we know that this I is negative because it's a virtual image, so I will be negative because magnification over here is negative, so and then we can get it as negative. But even if you don't write it, doesn't matter, it is or we'll just write it down. So I will just write it down so that there is no confusion later on regarding this particular part. And then comes the formula 1 upon V minus 1 upon U, 1 upon V minus 1 upon U is equals to 1 upon F. So accordingly, 1 upon 30 minus 1 upon minus 15 is equals to 1 upon F. So that is nothing but 1 upon 30 plus 1 upon 15 is equals to 1 upon F. So 1 plus 2 upon 30 is equals to 1 upon F. Therefore 3 upon 30 is equals to 1 upon F. So that will be F is equals to 10 centimeters. And that will be positive, as we know that the convex, the F is positive. So here we are getting it positive because of this particular thing. Okay, so this was sum number 1. We now move on to sum number 2. A concave lens. So the first thing over here is concave lens. Forms an image of an object kept at a distance of 20 centimeter in front of it. So U is equals to 20 centimeters, but it will be negative. And object kept at a distance 20 centimeter of it at a distance of 10 centimeter from on the side of the object. So here V is also going to be negative 10 centimeters. You need to find out what is the nature of the image, find the focal length of the lens. So first of all, M is equals to V upon U is equals to minus 10 upon minus 20. So that will be equal to 0.5. So therefore, nature of image is virtual and diminished. because it was positive, so it is virtual, and because it is less than 1, therefore it is diminished. Second part is 1 upon f is equals to 1 upon v minus 1 upon u. So that's 1 upon minus 10 minus 1 upon minus 20. It's equals to, this will be minus 2 plus 1 upon 20 is equals to minus 1 upon 20. Therefore, f is equals to minus 20 centimeter. Okay, so it is minus 20 centimeter. So it will be, this will be virtual. Yeah, virtual will always be erect. So we will just add over here erect and diminished, and the 20 centimeter negative. So negative important over here. That was sum number 2. We now move on to sum number 3. The focal length of a convex lens is 25 centimeters. So we are given that convex lens and f is equals to 25 centimeters. This will be positive because convex f is positive. At what distance from the optical center of the lens an object to be placed to obtain a virtual image of twice the size? So it is given over here that we need to find out u, which is going to be x, where v is equals to, we can say that the virtual image of twice the size. So we are given that I is equals to 2x, sorry, this is not, this is just like this, and O is equals to x, right? So accordingly, we need to find out the value of f. So first of all, we'll need to find out v, and then we'll take a f. So we know that I upon O is equals to v upon u. So this is 2x upon x is equals to v upon u. It is a convex thing over here. So because it's convex and it is giving a, they are given that it's a virtual image. So it's virtual image, so it will be positive only. So this is cancelling out. So accordingly, it is we can see that v is equals to 2u. Right? Now we have 1 upon f is equals to 1 upon v minus 1 upon u. We need to find out that where should the object be placed. That means u is what we need to find out. So we convert this into u. So 1 upon 25 is equals to 1 upon 2u minus 1 upon u. Right? So this will be equal to, this LCM is 2u. So this you multiply by 2. So it is 1 minus 2 upon 2u upon 1 upon 25. So 2u is equals to minus 25. So u is equals to minus 25 upon 2 is equals to minus 12.5 centimeter. So that's why u is 25 centimeters, and hence minus sign will say that it is in front. So that is 12.5 centimeter in front of lens. That's the answer. Okay. So that was sum number 3. We now move on to sum number 4. Where should an object be placed in front of a convex lens of focal length 0.12 meters? So first thing is convex again. Focal length is equals to 0.12 meters. To obtain a real image of size 3 times the size of the object. So object is equals to x, image is equals to 3x, and you need to give over here, so 3 times the size of the on a screen. So it's a real image. Because it's a real image, so this will be negative because real. Therefore I upon O is equals to v upon u. So therefore minus 3x upon x is equals to v upon u. Accordingly, we have that v is equals to minus 3u. Now we need to find out 1 upon f is equals to 1 upon v minus 1 upon u is equals to 1 upon minus 3u minus 1 upon u. So that will be equal minus of minus. This u will also be negative. So 1 sec. So you know that 1 upon 0.12, 0, that will be 1 upon 0.12 is equals to minus 1 minus 3 upon 3u. So 3u will be equal to minus 4 into 0.12. So u will be equal to minus 0.48 upon 3. So that will be minus 0.16. So u will be minus 0.16. That is what we found out as meters. So that will be 0.16 in front of lens. So answer will be 0.16 meters in front of lens. So where should I keep the object? It will be 0.16 meters in front of the lens. That was sum number 4. We now move on to sum number 5. Yeah, visible. Sum number 5. An illuminated object lies at a distance of 1 meter from the screen. So it's given that u is equals to, okay, it is, you need to identify the lens also, no? Convex lens, okay, so it's a convex lens. So it's given that u is equals to 1 meter from the lens. Sorry, an illuminated object lies at a distance of 1 meter from the screen. Okay, so the lens is in between, so this is not 1 meter. A convex lens is used to form the image of an object at the screen placed at a distance of 75 centimeters from the lens. So here, a convex lens is used to form an image of an object on a screen, okay, at a distance of 75 centimeters from the lens. So you got that u is equal to 75 centimeters. V is 75 centimeters and V is real, so it will be positive. Now it is given that the distance between the screen and the object is 1 meter. So if this is 75 centimeters, distance between screen and object is equals to 1 meter is equals to 100 centimeters. Therefore, u is equals to 100 minus 75 is equals to 25 centimeters. And u will be negative. Okay? You need to find out the focal length and the magnification. So first is 1 upon f is equals to 1 upon v minus 1 upon u. It's 1 upon 75 minus 1 upon minus 25. That's 1 plus 3 upon 75. That's 4 upon 75 is 1 upon f. So f is equals to 75 upon 4, which is nothing but 717 and 35 is 8 and then 32. So 30 will be 7 and then 5 za. So 18.75 centimeters is the focal length. We need to find out the magnification. M is equals to V upon U. Now V is 75 and U is minus 25. Therefore it is equals to minus 3. So that is real image. Magnification is 3 and it's a real image. So minus 3 will be the magnification. We move on to sum number 6. A lens forms the image of an object placed at a distance of 15 centimeters from it and a distance of 60 centimeters in front of it. So you can see that it is giving you a lens is form the image of an object placed at a distance of 15 centimeters at a distance of 60 centimeters. Now you can easily make out that this is a convex kind of a lens because the image is magnified, it's behind the mirror. Netar क्या होता है, image will always be, in case of concave, it is always in between the object and the lens. Here it is behind the object. So that's why we know that it is, since we'll write down the data first. So first the data is object is displayed at a distance of 15 centimeters from it. So U is equals to 15 centimeters. V is equals to 60 centimeters. And therefore, or we can write, since V is greater than U, therefore lens is convex and image is virtual and erect. Okay, so accordingly what will happen, if because the real, so this will be negative and this will also be negative, both will be negative. You need to find out the focal length, magnification and the nature of the image. So first thing is 1 upon f is 1 upon v minus 1 upon u is minus 1 upon minus 60 minus 1 upon minus 15. So that will be minus 1 plus 4 upon 60, that is 3 upon 60 is 1 upon 20, 1 upon f. So f is equals to 20 centimeters. Next is the magnification. So m is equals to v upon u is minus 60 upon minus 15 is equals to 4, hence virtual. Therefore the type of image, the third point is, the type of image is going to be, this is the first part, this is the second part. Third part is virtual, erect and magnified. Okay, the image will be formed, will be virtual, erect and magnified. See the next one, sum number 7. A lens forms the image of an object placed at a distance of 45 centimeters on it, on a screen placed at 90 centimeters. Screen दिया है virtual image as real image, so convex lens. So first thing is, seventh is, A part is convex as real image. Object placed at 45 centimeters from it on a screen placed at 90 centimeters. So we say U is equals to 45, so minus 45 centimeters. V is equals to positive 90 centimeters. Name the lens. Yeah, we name the lens as convex. Find the focal length and magnification. So 1 upon f is equals to 1 upon v minus 1 upon u is 1 upon 90 minus or minus 45. That's 1 plus 2 upon 90 is 3 upon 90. So that's f is equals to 30 centimeter. Okay, and then is magnification. Magnification is v upon u, that is going to be 90 upon minus 45 is equals to minus 2, that is real image. We come to sum number 8. An object is placed at a distance of 20 centimeters in front of a concave lens. So the first sum over here with concave. Now we had one more sum of concave. Object placed at 20 centimeters in front of a focal length 20. So U is equals to minus 20 centimeters. F is equals to minus 20 centimeters. Position and magnification. So 1 upon f is equals to 1 upon v minus 1 upon u. So 1 upon f plus 1 upon u is equals to 1 upon v. So 1 upon minus 20 plus 1 upon minus 20 is equals to 1 upon v. So this will be 2 upon minus 20 is equals to 1 upon V. That will be V is equals to minus 10 centimeters. Okay, V is minus 10. That means it's a virtual image. So here we'll have to write over here that V is equals to 10 centimeters in front of lens. Okay, it is not behind the lens, it is in front of lens because it's a virtual image. Magnification is asked. Magnification is equals to V upon U is equals to 10 upon minus 20. So that will be minus 0.5 virtual. Okay, that was the magnification. Minus plus 0.5 virtual. Yes. Sum number 9. A convex lens forms an inverted image of size same as that of the object, which is placed at a distance of 60 centimeters in front of the lens. As such, if we see the diagram, we can always know that if it is at 60 centimeters and same size, so V or U dono same hi rahega, but we cannot unfortunately write that thing. We'll need to write it in a proper manner. So first thing is we have got convex lens. We got U is equals to minus 60 centimeters. We have got M is equals to 1. They have given M is equals to 1 and it is a real image, so it will be minus 1. Therefore, M is equals to V upon U, so minus 1 is equals to V upon minus 60. So therefore, V is equals to 60 centimeters. Got it? So V is 60 centimeters. We got it directly from here that so V is equals to 60 centimeters behind lens. We need to find out the focal length. So 1 upon F is equals to 1 upon V minus 1 upon U. It's 1 upon 60 minus 1 upon minus 60. That's 2 upon 60 is 1 upon 30. So F is equals to 30 centimeters. Clear? This was sum number 9. Got it? Once you are going through the rhythm of this particular thing, it becomes easier. So mainly is you need to remember the sign conventions. That's why I wrote it over here so that we are not making any mistake while doing the sums. We now move on to sum number 10. A concave lens, yes, concave. A concave lens forms an erect image of 1/3 size of the object which is placed at a distance of 30 centimeters in front of the lens. So we have got M is equals to 1 upon 3 where U is equals to object is placed at a distance of 30 centimeters in front of the lens. So 30 centimeters. So this is negative and this will be virtual. So 1/3 will be positive. So we know M is equals to V upon U. So 1 upon 3 is equals to V upon minus 30. So it will be minus 30 upon 3 is equals to V. So V is equals to minus 10 centimeters. So we see that, yeah, V always be negative. So V is 10 centimeters. So yeah, we can write it as 10 centimeters in front of lens. Now you must have seen that I write over here in front of lens, behind the lens. What is that thing? Whenever you are writing about the position of V or U, if you are writing negative, so see, in case of U, we very well know that it has to be in front of the lens. उसमें कुछ ये नहीं है. There is no doubt because you are always going to place it in front of the lens. तभी तो तुम्हें image मिलेगा. Whereas the distance of the image, it could be either behind the lens or it could be in front of the lens. So when you are getting a negative, you write over here 10 centimeters in front of the lens. When you have got it in positive, you write it as 60 centimeter behind the lens. So accordingly, you are going to write this phrase behind the lens for negative and in front of the lens for positive. You need to write the focal length also. So 1 upon f is equals to 1 upon v minus 1 upon u is 1 upon minus 10 minus 1 upon minus 30. So that is going to be minus 3 plus 1 upon 30. That's minus 2 upon 30. That will be f is equals to minus 15 centimeters. So of course it will be negative because all f is negative in concave. So this was a concave lens, that's why it is negative. We move forward to sum number 11. Now the sums are based on the power, so simpler. 11. The power of a lens is plus 2d. So power is equals to plus 2.0d. You need to find out the focal length and the kind of the lens. So because it is positive, we know it is convex. So lens is convex. Okay. And then we talk about the P is equals to 1 upon F. So 2 is equals to 1 upon F. F is equals to 1 upon 2 is equals to 0.5 meters or 50 centimeters. So F is 50. Sum number 12. Express the power with sign of a concave lens of focal length 20. So we have got F is equals to 20 centimeters. So power is equals to 1 upon F, that is equals to 0.2. So that is 1 upon 0.2 is equals to 10 upon 2 is equal to 5. Diopter. Now this is concave. So since concave, therefore P is equals to, it's going to be minus 5.0D. Okay, minus 5D concave. We move on to sum number 13. The focal length of a convex lens is 25. So it's given F is equals to 25 centimeters. So P is, or we can get, is equals to 0.25 meters. P is equals to 1 upon F is 1 upon 0.25 is equals to 100 upon 25 is equals to 4. So that's 4D. Now what is the kind of lens given to you? It is convex. Therefore P is equals to plus 4D since convex. We see the last sum, sum number 14. The power of the lens is minus 2D, so power is equals to minus 2.0D. So lens is concave because negative. And find the focal length. So P is equals to 1 upon F. So 2 is equals to 1 upon F. F is equals to 1 upon 2. F is equals to 0.5 meters is equals to 50 centimeters concave. Okay. So that was sum number 14. So this is how we do the numericals of the sign conventions and the lens formula. Okay, so be very careful. You have got too much confusion regarding the signs. So whenever you write any particular kind of a sum, you need to write over there positive, negative over there very clearly. You need to mention that 30 centimeter bracket mein dal do, minus, negative, positive, la dal do. Okay, like what I put it in the earlier part. So you will always try to write the sign conventions along with the values over here. Okay, so this was about the this part of the chapter. we are left with the last part of the chapter, that is the magnifying glass and the application of the lenses, which we will take up in the next video.